Characterizing the existing network and sites. This is the fourth segment of applying methodology to a design video. Characterizing the existing network and sites. The second step of the design methodology is characterizing the existing network and sites. Information collected and documented in this step is important because the design might depend on the existing network's hardware, software, and link capacity. So in many cases, a network already exists and the network design relies on reconstructing and upgrading the existing network and sites. Even when a network does not exist, the sites that will be networked still should be examined. So the following section presents insights into the process of examining the existing network and sites and describe the tools used to gather the data, assess the network, and analyze the network. So a checklist to assess the network's health is presented. Guidelines for creating a summary report are introduced. The discussion concludes with a draft design document and estimates of the time required to complete the entire characterization process. Let's get started. The first step in characterizing the existing network and sites is to gather as much information about them. Okay, so typically based on the following input. So customer support. Okay, that's step one. So review the existing document about the network and use verbal input from the customer to obtain a first impression about the network. Although this step is mandatory, it is usually insufficient and some results might be incorrect. Okay, so you could have step two instead. Okay, so network audit. So perform a network audit, also called an assessment, which reveals details of the network and augments the customer's description. Okay, third would be traffic analysis. All right, so if possible, use traffic analysis to provide information about the applications and protocols used to reveal the shortcomings of the network. So take note that although traffic analysis is a good idea in principle, it is often too costly in terms of time and effort to do it in practice. Okay, now let's focus on the first one, which is the customer input. Okay, now customer input includes all pertinent network and site documentations. Some items the designer could request depending on the scope of the project includes the following. You could ask for site contact information, especially needed if remote deployments are planned. You could also ask for the existing network infrastructure from physical diagrams and documents, okay, so to logical diagrams if there would be any. Okay, so the locations and types of servers, including a list of network applications supported, locations and types of network devices. Okay, what else? Cabling. Okay, so that is currently in place, including interface connections. Okay, tables and worksheets is also important. So wiring closets or the telecommunication closets, environmental controls, including heating, ventilation, and air conditioning requirements, and filtration. Locations of telephone service, demarcation points, WAN speeds, and location of WAN connection feeds, locations of power receptacles, and availability of additional receptacles and power sources. Okay, so existing network, okay, from logical topology diagrams, including the addressing scheme, that's very important, and routing protocols in use. So you also have to consider infrastructure services supported, such as voice, storage, and wireless services. Now, information about the expected network functionality, okay, should also be considered. So this documentation should allow the designer to determine information about the planned and existing network and sites, including network topology, okay, includes devices, physical and logical links, external connections, bandwidth of connections, frame types, IP addressing, routing protocols, and so forth. Okay, so all of those are important considerations. Network services include security, quality of service, high availability, storage service, wireless, and so forth. And of course, the network applications. Examples includes the messaging and the video delivery or the learning management systems. Okay. Now, all this information should be included in the design document. It also forms the basis for breaking the network into modules. Identifying major features of the network. So, sample site contact information. Okay. So, site contact information is especially important for projects involving remote deployments when equipment delivery and installations must be coordinated. So, that is the site contact information. The customer might provide all the necessary site contact information, or the designer might have to conduct a physical site audit to obtain the necessary information. So, sample site contact questions. So, while at site, the designer can also obtain other information. For example, the power availability can be determined by examining the existing wiring closets. Okay? Digital pictures taken by a remote site contact can help in getting a quick sense of remote environment. So the table here illustrates a sample site contact form. Okay? So questions asked. Okay? So what is the site or location name, site address, shipping address, who is the site contact? Okay? Is the site owned and maintained by the customer? Is this staff site? What are the hours of operations? Okay, so what are the building and room access procedures? Are there any special security or safety procedures or protocols? Are there any union labor requirements or procedures? And what are the locations of the equipment cabinets and racks? So those has to be considered. So I have here an example of a high-level network diagram. Okay, so this is the customer network diagram here. So this figure shows the high-level topology of a sample network provided by the customer. Okay, so with only this diagram, okay, so what can you see here? So there would be many questions remain about the network and expected network functionality. So what are those? So maybe the first question would be, where's the IP addressing? Or what is the IP addressing scheme? What level of redundancy or high availability currently exists in the network? Okay. What level of redundancy or high level availability is required in the new network? Something like, what are the details of the security design? What types of links are in the network? It's all lines, all right? So it should be properly labeled also. So what are the link speeds? What are the planned layer 2 and layer 3 topologies? How is connectivity provided to remote sites? What network infrastructure services are in use, such as voice and video? What is the plan? Okay. So are existing wireless devices in place? So if there are wireless devices on the given diagram, okay, or what routing protocols are in use? Are there any server farm or remote data center connectivity requirements? Okay, what network management tools are in place? So it is important to get as much information as possible about the existing situation before commencing the design. Auditing or assessing the existing network. So a network audit or assessment is the second step in acquiring information about the existing network. So the auditing process starts by consolidating existing information the customer provides. Up-to-date information can be gathered from the existing management software used by the customers. If the customer has insufficient tools, the designer can choose to temporarily introduce additional software tools. If they are useful, then these tools can be used in the network permanently during the operate and optimize phases of the PPDIO model. Now, in audit, an audit provides details such as the following: a list of devices, hardware specifications and versions, and software versions of network devices, configurations of network devices, output of various auditing tools to verify and augment the existing documentation, link, CPU and memory utilization of the network devices. So that's also important. A list of unused ports, modules, and slots in the network devices. That is to be used to understand whether the network is expandable or not. Now, this figure here illustrates three different sources of information that can be used in auditing processes. So you've got the existing documentation, the existing tools, and the new tools. Now, auditing process might require minor or temporary network changes. Automated auditing should be used in large networks or enterprise networks, for which a manual approach would take too much time. However, the audit process balances both detail and effort to produce as much information as needed or possible. So for example, it should not require the large set of CPU-heavy auditing tools be purchased and installed in the customer network to collect configuration of network devices. So the auditing process is typically performed from the central location, such as location in a secure environment that has access to all network devices. So this figure here illustrates a sample information that a manual or automated auditing process collects from the network management workstation. The auditing process should collect all information relevant. And that should be relevant to the design. The same process should be used for all the network devices affected by the design. Now, what are the tools for assessing the network? A small network can be assessed without special tools. Monitoring commands can be used to collect relevant information on a small number of network devices. The approach can be semi-automated or it could be manual. Now, the approach on the semi-automated by introducing scripting tools to execute the monitoring commands automatically will speed up the process. So in a large network, a manual auditing approach is too much time-consuming and less reliable. So the following are some of the special tools that can be used to collect the relevant information from the network devices. So take note, you can use any available proprietary and open tools like Cisco works. This is used to map network and collect various types of information such as network topology, hardware, software versions, configurations, and so on. So you could also use third-party like WhatsApp Gold, Castle Rock, SNMPC, open source, Cacti, NetCordia, NetMRI, and NetQoS, NetVoyant, and so on. Other tools can help characterize the existing environment. For example, instead of a full wireless site survey, it can be helpful to conduct a brief RF sample of the environment using the enterprise level tools, such as Air Magnet, you've got the Aeropeak, and others. So you also have the Conyo Spectrum Expert. This is a spectrum analysis tool. And you could also have these laptop applications such as the Aeropeak. So from Wild Packets. All right. So a lot of tools would be available, for the network assessment. Manual information collection example. So commands for manual information collection. So the auditing process can be performed manually on relatively small network using various monitoring commands. Now the figure here illustrates three different types of network devices. Okay, information to be collected and commands that can be used to obtain information. So on the Cisco routers that run Cisco iOS software, the show tech support, okay, the show processes CPU, okay, you also have the show processes memory, so you can use that on Cisco devices. On Cisco switches, okay, so you also have this show version, show running config, and other commands. Okay, on the Cisco secure PIX security appliances, you could have show versions and write terminal. Okay, now this would totally depend on the available devices on the organization. So this is just an example, assuming that the organization is using the Cisco equipment. Now the figure here illustrates a sample output from show processes CPU command on a Cisco router. The output displays information about the network device utilization, which is important for describing the network health. Another example here, okay, so this figure illustrates a sample output from the show processes memory command on a Cisco router. Now using other tools like the Cacti device list here, okay, shown, automatic information collection example. Okay, the figure is a screenshot of an open source Cacti application or Cacti showing the list of devices found in the network. You also have here the screenshot from the Net MRI appliance from NetCordia. So the inventory results are expanded to view the Cisco CAT 4506 devices, including IP addresses, device names, and operating system versions. Network traffic analysis. So analyzing network traffic and applications. Traffic analysis is the third step in characterizing a network. So traffic analysis verifies the set of applications and protocols used in the network and determines the application's traffic patterns. So it might reveal any additional applications or protocols running on the network. Each discovered application and protocols should be described in the following terms: importance to the customer, quality of service related requirements, security related requirements, and scope. Okay, so in other words, the network module in which the application or protocol is used. So use the following interactive approach as illustrated in the figure to create a list of applications and protocols used in the network. So step 1, okay, use customer input to list expected applications. Step 2, use traffic analyzers to verify the customer's list of applications. Step 3, present the customer with a new list of applications and discuss discrepancies. And then fourth would be generate the final list of applications and their requirements, importance, quality of service, security as defined by the customers. Now assume that a customer requirement concerns quality of service on a wide area network connection with limited bandwidth. So in this case, the information collected is relevant because it describes the following. So the application TCP port 5151, which is required for performing classification, for instance. The importance of the application, this information is useful for evaluating how much bandwidth should be allocated to the application. The current bandwidth consumption according to the present quality of service implementation. Okay? So take note, however, that this information might not be relevant should the customer requirement instead concern a secure and resilient internet connection. Okay? So in that case, it might be necessary to gather information or additional information. Network analysis tools. So tools used for traffic analysis range from manual identification of application using the Cisco iOS software commands to those in which dedicated software or hardware-based analyzers capture live packets or use the simple network management protocol SNMP, which is an open software, to gather information or interface information. So analysis tools includes the following. So you've got the NBAR. Okay, this is the network-based application recognition. NBAR can be used to identify the presence of well-known applications and protocols in the network. You also have the NetFlow. NetFlow is an integral part of the Cisco iOS software that collects and measures data as it enters specific routers or switch interfaces. So NetFlow allows the identification of lesser-known application because it gathers information about every flow of the packet. Now, this information can be collected manually by using the Cisco iOS show IP cache flow command. Okay, so for every automated process, there must be a corresponding manual commands that can do the same. Okay, so alternatively, the Cisco Network Service or CNS NetFlow Collection Engine or NFC allows automatic information gathering of each flow in the network segment. So third-party or software-based products can be used to analyze traffic in different subnets of the network. So examples of those are this open source Cacti. Okay, you've got the Network General Sniffer, Wild Packets Etherpeak or Aeropeak, the SolarWinds Orion, Wireshark is a very popular tool, and Armon probes. So remote monitoring probes can also be used to support traffic analysis. So the following section includes examples of those tools. Okay, so this diagram here shows a Cisco iOS NBAR show IP NBAR protocol discovery command. So what it does, this command shows the statistics gathered by NBAR protocol discovery feature, which provides an easy way to discover application protocols that are transmitting or transiting in an interface. So you can use also other protocols that can do the same. So the protocol discovery feature discovers any protocol traffic supported by NBAR and can be used to monitor both input and output traffic. Okay. Next would be, this is an example of the NetFlow printout. So this provides a sample output from the show IP cache flow command, illustrating statistics gathered by the NetFlow switching feature. Okay, so by analyzing NetFlow data, a designer can identify the cause of congestions because you've got the number of packets there. Okay, determine the class of service for each user and application, and identify the traffic source and destination network. So basically, this NetFlow allows extremely granular and accurate traffic measurements and high-level aggregated traffic collection. Other network analysis tools like Cacti here, Cacti graph. Okay, so this figure shows a sample output from Cacti tool illustrating the daily throughput on a link. Okay. Also, another example here is a SolarWinds Orion output. So the figure is an example of utilization table from SolarWinds Orion tool illustrating the current percentage utilization on the top 25 interfaces. Okay. Summary report. The result of the network characterization is a summary report that describes the network health. So the customer input, network audit, and traffic analysis should provide enough information to identify possible problem in the existing network. The collected information must be collated into a concise summary report that identifies the following. So you've got features required in the network, possible drawbacks of and problems in the existing network, actions needed to support the new network's requirements and features. With this information, the designers should be able to propose hardware and software upgrades to support the customer requirements or to influence a change in requirements. So the summary report conclusions should identify the existing infrastructure shortcomings. So we have here an example of equipment summary report. Okay. Now in the example, the quality of service congestion management or queuing is required. So however, the designer has identified that Cisco iOS software version 12.0 does not support the newest queuing technologies. So in addition, some routers do not have enough RAM and flash memory for an upgrade. So the figure presents a sample summary report that identifies different aspects of network infrastructure. So summary report recommendations relate the existing network and the customer requirements. So these recommendations can be used to propose upgrading of hardware. You've got recommended actions there. Okay, not just the hardware and software to support the required features or modifying the customer requirements. So in this example, options include evaluating the necessity of the queuing requirement in the wide area network, creating a draft design document. So after thoroughly examining the existing network, the designer creates a draft design document. So the figure illustrates a draft design document's index, okay, not yet fully developed, including the section that describes the existing network. The design requirements and existing network infrastructure chapters of the design document are closely related. Examining the existing network can result in changes to the design requirements. So data from both chapters directly influence the network design. Okay. Now, typical draft documentation for existing network should include the following items. Okay. So there should be a logical layer 3 topology map or maps. Divide the topology into network modules if the network is too large to fit onto one topology map. Okay. So you also need the physical layer 1 topology map or maps, the network audit results, including the types of traffic in the network, the traffic congestion points, and the suboptimal traffic paths, and so on. Okay. So a summary section, okay, describing the major network services used in the existing network, such as maybe they have utilized OSPF or the Open Shortest Path First Routing Protocol, the Border Gateway Protocol or BGP, and the Internet Protocol Security or IPsec. So a summary description of applications and overlay services used in the network should also be included. Also, a summary description of issues that might affect the design or the established design requirements. A list of existing network devices with the platform and software versions. Also, you have to consider configurations of existing network devices. So usually attached as either a separate document or an appendix in a large document. Okay. Time estimates for performing network characterization. So this section provides some guidelines to estimate how long it may take to characterize the network. So the time required to characterize the network varies significantly depending on factors such as the following. Okay, so the experience of the network engineer, the quality of documentation provided by the customer, and the quality of the communication with the customer. the size and complexity of the network, the efficiency of network management and discovery tools, whether or not the network devices are carefully managed via SNMP, or how much information is needed to scope the project. So the figure here provides a range of time estimates in hours, okay, for characterization of networks in a variety of sizes. So these estimates assume a highly skilled professional or network engineer with efficient automated tools for network discovery and performance gathering, and a network in which the devices communicate with SNMP. All right. So the network characterization includes strategic evaluation and possible network redesign. So the steps in this diagram here, okay, interviewing the management team to gather the goals and constraints, interviewing the network team, okay, so to gather goals, constraints, documentations, and diagrams. All right. So you also have reviewing the documentations and diagrams and clarifying items with the site team. Okay. Also, setting up the network discovery tool, which typically involves using automated discovery or entering a device list or static addresses range into the tool, verifying the tool has found most routers and switches, and starting to collect performance data. So for discovery, we are using the Cisco Discovery Tool or the Cisco Discovery Protocol, CDP. You also have LLDP for open systems. All right. Next would be resolving SNMP access and similar problems if devices have not been carefully managed in the past. Allowing discovery tool to gather data. The time for this step will vary depending on the network sizes and should include seasonal or cyclical factors, but generally 1 week of data is sufficient. Okay? The network engineer typically does not need to oversee this process. Next would be analyzing the captured data. Minimizing the time required is dependent on the use of efficient tools. Okay? Next would be preparing high-level or layer 3 designs or diagrams for the proposed network. You also have preparing the report of conclusion and recommendations. Okay? Now, consequently, network characterization typically takes from 1 to many weeks, okay, depending on the size and complexity of the network and other factors mentioned at the beginning of this video lecture. So, summary. Characterizing an existing network entails gathering as much information about the network as possible. So, organization input, the network audit, and traffic analysis provides the key information that you need. Identifying major features of the network involves gathering network documentation and querying the organization. Data gathering is at most priority. The auditing process adds details to the initial network documentation that you created from existing documentation and customer input. You can manually audit a small network, but you typically need automated tools as presented to audit a large network. So traffic analysis verifies the set of applications and protocols used in the network and determines the traffic patterns of the applications. Also, tools used for traffic analysis range from manual identification of application using proprietary and non-proprietary tools. The result of the network characterization is a summary report describing the health of the network.